Okay, so let's talk about how to use this undo login to help us do the crash recovery. And we have used this example in the previous page, right, to show the basic actions we can do in a transaction. If you still remember in this table, right, the rows denote the actions, the basic actions. The columns denote the internal state for the transaction. It covers both the state of the temporary variable t as well as the values for a, b in the memory and on the disk, right? And in this example, in this page, we first add one more column to the table, the next column denoting the entries in the log file. As the system progresses for the transaction, we need to add some entries to the log file accordingly, right? Before we do anything in the transaction, we have to add one entry into the log file. It denotes start t. T denotes the transaction ID, right? And then let's do the read, right? So for all the readings in the transaction, we add those entries to the log file actually. We only log these writing actions in the log file, right? If you still remember. So for the read AT, we have no entries for the log file, right? We only copy the value from memory A to the T variable, right? And we double its value. Nothing changes for the log file actually. And we can do the write AT. We know in the following step we have to output is A, right? However, before in the previous page we mentioned one rule for the undo login. It's called write ahead login. In other words, before we write its A value back to the disk, we have to add one entry, right? It's called TXV, we showed before, right? To the log file. So therefore, we have to add one record to log file after we finish write AT. Even though right now we didn't write its A value back to the disk yet. However, according to the write ahead login, this rule, we have to add this entry before we write this 16 back to the disk, right? The entry we write here is called TA8. T is the transaction ID, it's very simple, right? A is a variable ID, right? It's for the element A. 8 is a value, it's very interesting. Currently, we have this A value to be 16, however, its old value is 8. Remember, for the undo login, for the V value, we keep a record of the old values, right? Before we do the writings, what's the old value for the A element? According to this example, this old value is 8. Therefore, in this undo login, we have TA8 into log. This 8 is the old value, right? Okay, so then we can do the read BT and the following steps. And after we finish the write BT, in other words, we copy the value from T variable to the memory B, right? Also because of this write ahead this login, this rule, we have to add one more entry to the log file before we actually write this 16 back to the disk, right? So therefore we have one entry, TB8, transaction ID, element ID, 8 is the old value for B, right? Before we write back the 16 to the disk B, its old value is 8. We have to keep records of the old value before we write them back to the disk, right? So these two records are following this write ahead login, this rule, right? And then we have this output A and output B. It means we can copy the values from memory A to the disk A, as well as memory B to disk B, right? So then here we have to follow another rule. It's called the net commit rule, right? We mentioned before. After all the writings back to the disk, they are finished. Then we can add one more entry to the log file, commit T, right? It's called the net commit rule, right? We showed before. After both the output A and output B, it means we output all the values from memory to the disk. They are taking effects already. Then we can commit them, commit T here, right, into the log file. Before we do anything, we have to start T. Before we write the values back to the disk, we have to follow this write ahead rule, right? Adding this TXV or TA8, TB8 in the log file. And after we write everything to the disk, then we can add this commit T, right? Following this net commit rule, as we mentioned before for the undo login. Okay, so this is the example. And let's see how to use this undo login for us to have the crash recovery. So once the system crashes, the system will know this recovery manager automatically. Recovery manager is a program or the process in the DBMS, it will be noted by the system. So when the recovery manager is noted and running, it will decide whether each transaction is completed or not. Here, completed is different from commit we mentioned before, right? Completed means the transaction is finished, no matter whether it is finished successful or not. To decide if a transaction is completed or not, we will check the log file, right? If for a transaction in the log file, we see the pair start T and the word commit T, because we are following this undo login, right? If we see the commit T for the transaction, it means this transaction is finished successfully, right? And all the writing has been returned to the disk already. If we see this pair in the log file for T, it means this transaction is finished completely, right? Another case is that if we see a pair start T and abort T, it means it is all completed, even though during the runtime we've had some problems for this transaction, right? However, it is completed, even though we make some mistakes. And for the remaining transactions, if we only see the start T, we don't see any abort T or commit T after it, it means before we finish this transaction, the system crashes. This transaction T is not completed, right? So the general idea for the undo login is to undo all the modifications by these incomplete transactions, because all the completed transactions, they have no effects or change the state for the database system, right? So before the crashes, if they are completed already and the system is consistent, then after crashes, all the completed transactions will have no effects for the inconsistent state of these transactions, right? And we have to undo all these incomplete transactions only. So the high-level idea for the crash recovery to the undo is the crash recovery manager will read undo log from the end. If we see a complete T, we mark this transaction T as completed. If we see abort T, we also mark this T as completed, because we are reading the undo login from the end up or bottom up, right? If we see a TXV, however, T is not completed, it means for this transaction, we only have this start T, we never see the commit T or abort T, right? This T is not completed, then we have to undo this action, TXV. If we see the TXV, it means we write this value for this act, right? Here this V denotes the old value. If this T is not completed, then we can write X equals to V to disk. In other words, we can recover the old value for this X element, right? Or if this T is completed, then we can ignore it, because we know we have this transaction will have no impacts for the consistent states of the database system. If we read one line with start T, we can just ignore it. Right, you follow me, right? So if we have this commit T or abort T, that means this transaction T is completed. However, if we see one record TXV and this T is not marked as completed, it means during the runtime of this transaction T, the system crashes. And then we have to recover all the values for this X to its old value, right? And in this way, we can make sure this system will recover to a consistent state before this T starts. Okay, so this is a general high-level idea for the crash recovery with undo. We will show you the example about how to use this undo login to help us do the crash recovery.